Alright, a little late in the day for this, but let's see if my nap refreshed me enough to do this. Alright, minimum removals to balance array. The good thing about arrays is it's very, anything with an array is kind of bare. Arrays should be the most well-known data structure, so anything that requires you to manipulate it, it can't really be classified as anything besides a fair difficulty problem. Alright, we're given an integer array nums and an integer k. An array is considered balanced if the value of its maximum element is at most k times the minimum element. Okay. The value of its maximum element is at most k times, so multiple. You may remove any number of elements from nums without making it empty. Okay. Return the minimum number of elements to remove so that the remaining array is balanced. The minimum number. Sure, actually, okay. 2, 1, k is 2, you need to remove 5, that's one element. K is 3, so you want something that's 3 parts of 2, 2, 6, so you need to remove 1, 9. No, wait. Just the 9, because the 6 is the 1 can stay. The 6 will be the maximum of that. Wait, no. No, you do need to remove the 1, because the 1 would be the minimum of 162. So you need 1 and 9. Then you can't do this. Okay, sure. Okay, so I'm thinking about if I sort the array, sorting the array would make it so that 1629, the sample 2, would become 1269. At that point, what I'm looking for is the longest array, kind of, where the first and last value of that array has a multiplier of k. The first value times k is the last value. So I'm just looking for that. I think sorting should probably be fine unless there's a solution that is faster than sorting. Would there be a solution faster than sorting? Oh no, I can't sort this, right? No, I can because I'm removing elements. So I'm keeping elements. I think sorting, I don't see how. I'm trying to think of a faster than sorting, so a linear approach. Can't imagine how a linear approach could actually work here. Well, can I? No, I can't. You can't use a stack here or I don't think you can use a monotonic stack or monotonic array. Because you do need to worry about the sorting order here. It really does not matter the randomized order. The sorting order is the only thing that you need to really be concerned with, and also if it's in randomized order, you'll eventually need to sort to kind of determine what the count of things, right? The frequency of the small values, the frequency of the things bigger than it, and whatever. Okay, so sorting first. And then just the longest, the longest lane from the start to k. So I wonder if I can do sliding window. Yeah, I think I can do sliding window here. Like the right side window is the bigger value, and while the left side window, yeah, this is definitely sliding window. Try to maintain a window where right side where maintain window where min value to times 3 or min value, which is the first left value times k equals right max value, which is the right value. That's the that's the invariant. And in general, it'll be something like increment use for loop to iterate over right index. Or create a left index while left indexes, well, basically left value, the value at the left index is less than times k. K is less than right value increment left index if left value is equal to or times k equals to right value. Check length if longer than stored max. Update after loop return stored max. And the stored max I can just refer to as the answer. I'll start with answer is infinity. It needs to be, no, answer needs to be 0, right? Because I'm updating bigger. Answer equals 0. And then what's the impossible answer? 0. An array of size 1 is considered balanced as its maximum, minimum are equal and the condition is always true. Okay, let's go ahead and just handle that case separately. I don't know if this idea would do it correctly. Length of nums equals, well, I guess I can probably create the variable here. If n is the length of nums, if n equals 1, return 0. K equals 2, so there's wait, what? Oh, it's at most k times the, I see. It's at most k times. I wonder if it would handle, oh, we'll test. Okay, so let's say the left index is going to be at 0. I guess I can just say answer equals left equals 0. While right, oh not right, for right in range n, just need to do the invariant here. So always for sliding windows, you should have a for loop that iterates over the right index, have a inner loop that adjusts your left indice generally to make sure that your invariant holds, which in this case is trying to maintain that left side k is less than equal to, or more than equal to right, actually. While left less than, actually, I don't think I need to double check the indexing. While left times k is less than, is at most, so less than right, oops, left side. So nums at left times k is less than nums at right increment. And this will automatically, since k is at least 1, I think. Yeah, k is at least 1. This should stop at most when left is equal, right? Left would never go past that. Left plus, oh no. I think I would guess I always update here. If the length of this size of this array, which is inclusive of both left and right indices, so it should be right minus left plus 1. If it's not inclusive of one or the other, it would be just right minus left. Is greater than the answer. Answer equals right minus left plus 1. Return answer. Alright, I'm pretty confident with this. Confidence unfounded. Okay. Really? What is going on? Whoa. I'm a dum-dum. So the answer is just the length of the number of things, right? And then I need to actually adjust from the total. So that's not what the answer actually represents, or the variable should not be called the answer here. Answer should be, this is, I guess this is the longest or the widest. I'll just call it longest. Return answer implied by longest, basically total minus longest, since we're trying to find how many to delete from the array. Not quite Pythonic. I should be not leaving spaces between these expressions. But it does look sometimes easier, better to have spaces. Cool. Alright, so that is the summary. Summary, sliding window, there's always an invariant. This is the sliding window technique. That's that. Summary, time complexity, this is O of n log n to sort. And then O of n to iterate over the indices, doing constant work. And the sliding window algorithm on to process the array. So overall, it's O of n log n. Base complexity, this should be O of 1, since sorting is in place. And no extra kind of data structure was needed for the window. Just a couple variables.